Hi, welcome once more to Mr. Max. In this lesson, we are going to revise from September 2019 Free State. Okay, Free State Province, September 2019 question paper, probability section. That is question number 11. Okay, so download the question paper from our app, or you can go to their website. You can download the question paper there. Okay, and I have one more request for you. Before you watch this lesson, please make sure that you watch that first class of explaining the theory part. Okay, then if you watch this one, then you can easily understand. Okay, if you already studied that one at school, it's fine. Okay, otherwise you have to watch that first lessons, then you have to watch this. Okay, and one more thing, when I'm teaching this one, don't just watch like a movie or a film. Okay, you must have your paper and a pen and calculator with you. Okay, and just watch, and you have to write also. Otherwise, when you write your exam, maybe if you just watch as a movie and if you are not writing, practicing with your hand, then it is difficult for you to remember all these things. Okay, so it's better to practice like that. Okay, anyway, let's start question number 11.1. What is question number 11.1? MR.MATHSZA is visiting a restaurant. Good for her. What is the next sentence? The probability that she will order tea is 0.4 and the probability that she will order cake is 0.5. The probability that she will order tea or cake is 0.8. Wow. So from that sentence we have to write in probability terms. Okay, so first one, the probability that, so here all of these one are probabilities given. Okay, not the number. The probability that she will order tea is 0.4. so let me call T as T. Okay, so T as T, yeah, it's correct. T is T. Okay, then probability of she ordered T is 0.4, and the probability that she will order cake is 0.5. so probability of, let me say cake as C, not coffee. Probability of cake is 0.5. that is 1.5, 1.2, 1 by 2. Okay, 0.5. Then look at the next one. The probability that she will order tea or cake. What is the meaning of or? Or means union. You remember that one? Okay, and means intersection. Okay, so you have to remember this one. Okay, so the last one is probability that she will order tea or cake. So it means that probability of tea or means union. Tea union cake is equal to 0.8. so these are the things given. Okay, now based on this one, what is the first question? 11.1.1. 11.1.1, calculate the probability that 11.1.1a, you have to find the probability. Okay, probability that MR.MATHSZA will order neither tea nor cake. Wow, what is that question? Probability of, you have to find the probability of neither tea nor cake. Then why she went to that restaurant? Yeah, that's okay. So what is the probability of neither tea nor cake? So here, what is the meaning of neither tea nor cake? It means that not tea, not cake. Okay, maybe she orders something else. Okay, so here mathematically how can we write this one, or probability terms how can we write this one? This is probabilistically we can write like this: probability of not cake or means, I mean first T. Okay, probability, just to avoid the same thing, but just to avoid confusion, not tea or cake. Or means what? Union. Okay, not T. Let me write one more step. Not tea or cake. You can write it like this, the same thing. This is the question. Neither, what is the probability of neither tea nor cake? How can we write like that? That one, probability of not tea or cake. That is the meaning of that one. Okay, not tea or cake. So now this one, how can we write? Or means union. Okay, not, how can we write? Not a, maybe those who watched that first lesson classes, you remember, not a, how can you write mathematically? Is it not the same as a complement, this one? Okay, you have to know that one to do this question. Okay, not a is the same as a complement. So here not T union C means that T union C complement. Okay, so not, okay, come back to this one, not T or C, that is the same as, look at how I am going to write, probability of, or means union, T union C complement. Mathematically you can write it like, probability terms you can write it like this. Okay, not T or C, T or a cake, it means that probability of T or cake complement, because this is what you studied. Not a, how can you write? That is the same as a complement. So instead of that a, here it is what? T union C. Okay, so not T union C means T union C complement. Okay, and one more thing, there you studied like this, probability of a complement is the same as 1 minus probability of a. Do you remember that equation? Probability of a complement is 1 minus probability of a. That you have to know. Okay, this is the expression for probability of a complement. Probability of a complement is 1 minus probability of a. So instead of this a, what is here? T union C, or T or cake. Okay, so how can we write that one? You have to listen very carefully. Look at how I am going to write probability of T union C. This is our A. This total is our A. So how can we read this? Probability of A complement, like that. Okay, so it is 1 minus probability of A. That means 1 minus T union C. Do you understand? Okay, so instead of this T union C, if we call, instead of this one, if we call as A, then you can understand, is it not the same as that one, probability of A complement? So 1 minus probability of A, like that. Okay, so anyway, 1 minus probability of T union C. What is our T union C? 0.8. Am I right? It is given in the question that T union C is 0.8. So how can we write this one now? 1 minus, this one is 1 minus 0.8. That is, check in your calculator, it is 0.2. Okay, so the answer of that probability of neither T nor cake is 0.2. Next question, let's go to the next question. 11.1.1b. Okay, 11.1.b. What is that one? B part, same one, B part. She will order tea or cake. Tea and cake. She will order, probability of, you have to find the probability. Okay, so probability of, she will order tea and cake. And means what? I already explained that one. And means intersection. Okay, so probability of tea and probability of she will order tea or and cake. So it is the same as probability of tea and means intersection, T intersection C. That is what you want to find. And means intersection. So in effect, what is the probability of she ordered tea and cake means that you have to find the probability of T intersection C. Okay, now how can you find this T intersection C? So for that, Do you remember the addition formula that you studied? Probability of A union B. Do you know the expansion, or do you remember the expansion of this one? A union B. You can write it like this: probability of A plus probability of B minus probability of A intersection B. Do you remember that formula? Probability of A union B, the expansion is like the addition formula. Probability of A plus probability of B minus probability of A intersection B. Okay, so there we can see that the last one, this is A intersection B. Yeah? So probability of A intersection B is here. And do you know what is probability of A union B? Or in our case, T and C. Instead of A and B, it is T and C. Okay, so here probability of T union C, we know that it is 0.8. Do you know what is probability of T? Probability of A, that is probability of T in our case. Okay, so it is probability of T we know. Probability of B, in our case it is C. Probability of C we know. So we can easily find this probability of A intersection B. You understand? So let me write that one in our case. Okay, so probability of A union B, in our case T and C. So T union cake is equal to probability of A. In our case T is A, so it is probability of T plus probability of B. In our case it is C. So probability of C minus probability of A intersection B. So what we have to write here? Probability of T intersection C. Okay, the only difference is there it is A and B, here it is T and C, that's all. Okay, in our question it is T and a cake. Okay, so now let's substitute the values that we know. Don't forget that what we want to find, this is what we want to find: probability of T intersection C, that means this one. Okay, so what is probability of T union C? It is 0.8. so substitute the values. 0.8 is equal to 0.8 is equal to probability of T 0.4 plus probability of C 0.5 minus probability of, this is what we want to find, intersection cake and T and cake. So take this one to the left side. So here it is minus. So if I take that one to the left side, it is positive. So it is probability of T intersection C is equal to, what is the sum of this one? 0.4 plus 0.5. You can use your calculator, or it is 0.9. Okay. Now this 0.8 on the left side, I have to take that one to the right side. Here it is positive. So what about on the right side? It is negative. Okay. So it is minus 0.8. So probability of T intersection C is equal to, check in your calculator, what is answer? 0.1. That means probability of she order tea and cake is 0.1. That means only 10% chance she order both. That's the meaning of that. Okay, let's go to next question, 11.1.2. Okay, let's go to next question number 11.1.2. 11.1.2. What is that question? Before I go to that question, what is the answer of the previous one? Intersection, probability of T intersection C. Probability of T intersection C. We got the answer as, remember previous question, 0.1. That's the answer. Okay, just leave it there. We want that one here in this question. Okay, 11.1.2. Let T and C represent the events T and cake respectively. We know that one. Okay, then are the events T and C are mutually exclusive? Motivate your answer. Are the events T and C are mutually exclusive? Motivate your answer. What is the meaning of that question, guys? Mutually exclusive. So mutually exclusive means that this is our T and this one must be our C. Okay, mutually exclusive means nothing common. It must be like this. There must not be any common for this T and C. Okay, but from the previous question, what we got? Probability of T intersection C is 0.1. What is the meaning of that? From the previous question, we know that this is our T and this is our C, and here common is, intersection means common, 0.1. You understand? Okay, so it means that there is something common between T and K. So is these two events T and K are mutually exclusive? It is not mutually exclusive. If it is to be mutually exclusive, then there must not be anything common. But in our case, we already proved that the common is, probability for the common is 0.1. That means there is something here from the previous question. So we can't say that T and C are mutually exclusive. Okay, so how can we write that one? First you have to write, are the events are mutually exclusive or not? So you must have to write it is not mutually exclusive. It is very important. 1 mark is for that yes or no. Okay, and then you have to write your answer. What is the reason, or justify. Okay, so what you have to write, probability of T intersection C is equal to 0.1 from the previous question. That is not equal to 0. That is enough. Then those who are marking your paper can understand, okay, what we mean by this. You are saying what you are trying to say. Probability of T intersection C is 0.1. Therefore, it is not 0. If it is not 0, then it is not mutually exclusive. You understand? Okay, so that is 11.1.2. now let's go to 11.2. question number 11.2. 11.2. 7 learners, Bonolo, Jeffrey, Themba, Richard, Tandeka, Godfrey and Palesa. How many learners are there? 7. Okay, are standing in a line. So there are 7 learners standing in a line. Okay, so there are 7 learners. Okay, 1 2 3 4 5 6 7. Okay, there are 7 learners standing in a line. Okay, now what, based on that one, 11.2.1. 11.2.1. what is that question? In how many ways can the learners be arranged in a line? So there are, how many are here? 1 2 3 4 5 6 7. Okay, so how many ways they can arrange? How many learners are there? 7. How many positions are there? 7. Can you say without explanation what is answer? 7 learners, 7 position. It is 7 factorial. How? You can just directly write 7 factorial. You will get the full mark. How many marks for that? 2 marks. Okay, you have to write the answer also. What is a 7 factorial? Okay, check in your calculator. That's all. Okay, there is no need to write it like this. Okay, so anyway, for you to understand how do you get this 7 factorial, just listen here. There are 7 learners here. Okay, so the first learner can come on this line here. That means from this 7, any one learner. That means here I have 7 options. So one of them came and stand here, then that one is out. So how many learners remaining here? It is 6. So here I have 6 options. So 2 people out from this line. So how many remaining there? Only 5. That means how many options I have here? 5 options. Here 4, here 3, here 2, and the last one must come and stand here. Is it not that same as 7 factorial? What is 7 factorial? 5000. You can check in your calculator, guys. I think it's 5040. Yeah, so it means that when you write your exam, it doesn't matter if you write it like this or you just write 7 factorial, that is 5040. You can write it like that. Okay, okay, that is first question. Now 11.2.2. 11.2.2. what is that question? In how many ways can the learners be arranged if Bonolo, Jeffrey and Themba must next to one another in any row? So now what is that question? In how many ways can the learners be arranged if Bonolo, Jeffrey and Themba, how many learners are there? 3 learners. Those 3 learners must be next to one another in any order. So here they are saying that, okay, let me erase this one. Here total how many possibilities are there? Total without any condition, how many possibilities are there? 5040. Don't forget that, we want that one. Okay, so total without any condition there are 5047 factorial different options. Okay, now let's go to the next question. 11.2.2. 11.2.2. what is that one? 3 learners, their names are also given. Okay, assume that these are the 3 learners. Okay, what is this one? That 3 learners wants to sit or stand next to one another in that order, in any order. Okay, so only one condition, these 3 must wants to sit next to each other. Excuse me. So in how many different ways they can stand? That is a question. Okay, so what you have to do, those who watch that lesson, first lessons, that PowerPoint presentation lesson, you can easily understand this one. What I told you at that time, you have to consider this as one unit. Okay, then you have to count 1, 2, 3. Okay, then 4, 5. So then write 5 factorial times. Okay, listen once more. You have to count these 3 as one group. They are moving together. Okay, so you have to consider this as one unit. Then how many different options? 1, 2, 3, 4, 5. That is 5 factorial. Okay, times in this group of 3, they can swap each other like that. You know, these are the 3 students, maybe like this, or they can sit like this, or they can sit like this. Am I right? Or this one come like here, or this one must come here. You understand? So in this group itself, they can stand how many options? 3 factorial different options. So the answer is 5 factorial times 3 factorial. Check in your calculator what is the answer for that one. Your calculator, I don't know, you can check in your calculator later. You must have to write the answer, it's very important, otherwise you will lose 1 mark. Okay, 11.2.3. what is the probability that, listen very carefully, underline that one. In this question you have to find the probability. Previous question just a number. Okay, now in this question, what is the probability that Tandeka and Palesa will not be stand next to each other? Tandeka and Palesa will not be stand next to each other. So how can you find that one, guys? So let me draw that one once more. To 11.2.3, let me write it here. 11.2.3. so here this is not the scenario. Okay, with that picture, don't misunderstand. Okay, what is that? Read that sentence. What is the probability that Tandeka and Palesa will not be stand next to each other? These two, assume that this is Palesa and Tandeka. Okay, so these two people must not stand, or they don't want to stand next to each other. What is the probability for that one? Do you understand? Okay, that is the question. Don't think that they want to stand to each other with this picture. Okay, just opposite. Okay, they don't want to stand next to each other. That is a question. You have to find the probability of that one. What is the probability of these two does not want to stand next to each other? So what I am going to do is, first I am going to find what is the probability of if they want to stand next to each other. First I am going to find what is the probability of if they want to stand next to each other. Okay, then what I'm going to find is if they don't want to stand next to each other. Total how many possibilities are there without any condition? Do you remember the first question? 5040. Do you remember that one? 7 factorial, that one. Okay, 5040. Okay, so if I can find, listen very carefully, if I can find if these two people wants to stand together, I will get a number here. Okay, so if I subtract this number from the total one, then I will get the probability of if they don't want to stand next to each other. Listen very carefully. In this type of questions, you are supposed to do like this. Okay, here our question is, listen very carefully, our question is these two guys doesn't want to stand next to each other. Am I right? Okay, so what you have to do is you have to find the you have to find how many times these two people wants to sit next to each other. Okay, then you subtract from the total option, then you will get that answer is the how many times those two people doesn't want to stand next to each other. Okay, listen once more, listen when I'm explaining this one, you will understand more clearly. So number of times those two, yeah, or you can write their names, those two wants to stand next to each other. Sorry for my funny handwriting, guys. Okay, number of times those two wants to stand next to each other. So how can you find? I told you, if there is a question like this, you have to consider this as 1 1, then you have to count 1 2 3 4 5 6. That means 6 factorial times inside this one how many? 2. That means they can stand either like this or like this. Okay, so it means that inside that one it is 2 factorial. Okay, so this is the number of times if they are standing next to each other. So now how can you find if they don't want to stand next to each other? Next one, number of times they doesn't wants to stand next to each other. So here in this one, what is that condition? They doesn't want to stand next to each other. Okay, so here here total how many possibilities are there without any condition? The first question 5040. Okay, so to find number of times that they doesn't want to stand next to each other, how can you find that 5040 minus the answer of this one? What is the answer of that one? 1440. Here you will get the answer as 1440. 1440. So if you subtract that total possibility minus this, they want to stand next to each other, you will get the number of that they doesn't want to stand next to each other. So that answer is 3600. Okay, now not finish. Look at that question. Now you have to find what is the probability that they doesn't want to stand next to each other. So now next step, you have to find the probability. It's not a big deal, but you have to write that one, otherwise you will lose 1 mark. Okay, so next one, therefore probability of they doesn't want to stand next to each other, okay, is equal to, you know how to find the probability. What is the number of times they doesn't want to stand next to each other? 3600. So it is 3600 divided by, without any condition, total how many possibilities? That is that 5040. So check in your calculator. What is answer? 0.71. That means the probability that they doesn't want to stand next to each other is 0.71. Okay, so listen once more. Question is, what is the probability of they doesn't want to stand next to each other? So what we did, first we find what is the probability of if they want to stand next to each other. Then we subtract from the total possibility 5040 minus that they want to stand. There you will get the number of times that they doesn't want to stand. So it is 3600. Since the question is to find the probability of that one, what you have to do? That 3600 divided by 5040. Okay, this is a frequent question, almost I saw in many question paper. Okay, so you have to understand this method. Okay, this is how you are supposed to find the answer of this question. Okay, so guys, that's the end of Free State September 2019 question paper, and I hope you understand. Okay, keep on watching. Thank you.